Hi, here we go. This is Math 2, Unit 10, Lesson 2, Homework Help. Looking at Form K for today's homework, and these are all the numbers I'm going to kind of run through today for just a little review. So here we go. Looking at number 1, first of all. Let's zoom in here a little bit so it's a little more focused. That's a little better. Awesome. Okay, so when we have an exponent to an exponent, our rule is simply to go ahead and multiply those two things together. So we take the v and we keep the v, and we have 4 times 2, and that becomes v to the 8th power. So when we have an exponent to an exponent, then we multiply those together. Remember our previous lesson, if the bases were the same, we added them together, but this is just one base, and we're doing an exponent to an exponential power. Looking at number 3, moving over here, we have n to the 4th, which is then to the negative 6th power. So that means I'm going to do n, and that's going to be 4 times a negative 6. Well, 4 times a negative 6 gives me a negative 24. And because I don't want to leave a negative up above there, that does mean to flip the whole thing over and to put it in the denominator. So I get 1 over n to the 24th power as my final answer there. Let's move over to number 4. Number 4, I have several things going on here. I have, first of all, I have h to the 1st power. Right, that's there by itself. I'm going to go ahead and bring that down. I have h to the 1st power. Now this exponent is connected to what's beside it in the parentheses. It's not connected to this first h. So this negative 10 only multiplies to the negative with the negative 3. So that gives me h to the negative 10 times negative 3 is positive 30. So now I have h to the 1st times h to the 3rd, and I'm back to lesson 10.1, which says if the bases are the same, now I'm going to add them together. 1 plus 30 is 31. So I have h to the 31st power. Number 8. Number 8 I wanted to do because it's a little different. All right. First of all, I can see this 8 is connected to the 2. So an 8 times 2 gives me m to the 16th power. Okay. So I'm in m to the 16th, no problem. Now I have n to the 0 power times 4. Well, it's not 4 times 0 is 0. Don't do that, or you'll end up with nothing. Remember that anything to the 0 power is actually 1. So what I really have is 1 to the 4th power, which is still 1, which means this all just basically goes away, and I'm left with just m to the 16th as my answer there. Alright? So if you had changed that to a 0, you would say your answer is 0, because 0 times n to the 16th would be 0. But n to the 0 is 1. So keep that in mind. Number 11. We have lots going on here. Now we've added a number in front of the variable. So what that means is I have to take this variable and I'm going to have to the exponent, sorry, and distribute it to the 3 and to the 4 right there. So let's do this one at a time. 3 to the 3rd power, I'd write like this. So I have 3 to the 3rd power. 4 times 3 is 12, so that becomes s to the 12th power. And I still have my s to the 2nd power hanging out there on its own. I'm not done yet because I do want to simplify. 3 to the 3rd, 3 times 3 is 9, 9 times 3 is 27. And now because these are the same bases, I'm going to add what I have, and 12 plus 2 is s to the 14th power. Alright, so the key there was to take my exponent and distribute it to the whole number and to the other exponent that is there. Alright, next one, number 12, kind of funky. I'm going to take this 1/5, and again I'm going to distribute it to the b, and I'm going to distribute it to the 3. Why the b? Well, this is b to the 1st power. So there is a number there, we just can't see it. Now you can. So the b becomes 1 times 1/5, which is b to the 1/5. c to the 3rd, 3 times 1/5 is simply 3/5. And that's actually all there is to it. You leave it just like that. b to the 1/5 c to the 3/5. And that's all we're doing. So it might look a little silly, but that's all we're doing for now. All right. Number 17. 17 has a lot of crazy things going on here, so let's see what we have. First of all, I have c to the 10th, so that can stay. C to the 10th, no problem. I have a 4, so I'm going to distribute this 4 to the 1/4. 1/4 times 4 is 1. So I have all that's left here is c to the 1st power, because 4 over 4 is 1. Keep going, I have a d still. Now this d is negative 3 times 4. Negative 3 times 4 is negative 12. And I still have a d to the 3rd on the outside. Now my job is to combine things together to get it all cleaned up. I have a 10 and a 1, so that gives me a c to the 11th power. I have a negative 12 and a positive 3, gives me d to the negative 9 power. But like we said before, I don't want to leave a negative exponent in the numerator, so that tells me to drop it into the denominator. So I'll rewrite it as c to the 11th over d to the 9th. And that'll be my final solution for number 17. Okay, let's look at a couple of the scientific notations. Again, I'm not sure if you have to do these or not, so I'm going to do 2 and then flip to the back side. Alright, so what I want to do here is I'm going to take my exponent and I'm going to square each part. So 4 squared becomes 16. The exponent 2 times 3 becomes 6. So I have 10 to the 6th. I can't stop there though because I don't want to have a double-digit number there for scientific notation. So if I move this digit over one space to make 1.6, then I also have to increase the number of exponents for my base 10 to 10 to the 7th power. Alright, I'm going to do another one just so you can kind of see how that worked again. So I squared it and then I had to move things over. So when I get to this guy here, number 21, 3, so 1.4 times 1.4 times 1.4, multiplying those out there. When I multiply that out, what I end up with is 2.744 times, and 3 times the negative 8 is 10 to the negative 24th. Alright? And remember up here we had to move things around. We had to get rid of no negatives. We wanted no negatives in the numerator. This is scientific notation, so we just leave it like that. We don't have to worry about changing stuff, so we'll just leave it. Alright. Flipping it over to number 36 on the back side. Nice little problem. We have 4 to the 3/2 power times 8d, and the whole thing is cubed. So we have a lot going on here, and so I wanted to kind of show you how this works. So we said before that the top number is our exponent and the bottom number is our radical. So this number is actually 4 to the 3rd squared. My exponent is the 3 and the radical is what's below, so squared there. So 4 times 4 is 16 times 4 is 64. So I actually have the square root of 64 for this portion so far. The square root of 64 is 8. Alright, so far I've only solved this portion or simplified that portion. Happens to be nice. Let's go ahead and play with the 8d to the 3rd. 8d to the 3rd means I'm going to take the 3, right? Take the d to the 3rd, and this gets cubed, so it's 8 to the 3rd, and the d also gets cubed. So now I have 8 to the 1st times 8 to the 3rd times d to the 3rd, which is basically 8 to the 4th times d to the 3rd. And you want to use your calculator for that because 8 to the 4th ends up being 4,096, and then d to the 3rd just stays what it is. So the tricky part in this problem wasn't so much the 8d to the 3rd it probably was this part here, and again, I'm not sure what you've covered in your class to show how to get from 4 3/2 to this right there. So, just wanted to show that again because I thought you might get stuck there, but maybe not. Let's look at number 37. This is scientific notation with a lot of exponents and things multiplied together. It's not as bad as it looks, so here we go. I first of all take the 10 to the 8th to the negative 5th power, and I'm going to multiply that together. 8 times negative 5 gives me 10 to the negative 40th. Okay. Now over here I have this crazy mess. So I'm going to go at 3 and 3.6. So when I cube that out, I end up with 46.7. So 3.6 to the third power is 46.7. The third power, 3.6 to the third power. And now here I just multiply those together. So I end up with 10 to the negative 24th. There. That's what's on the inside. The next step would be to then, well, let's see what I have next to do. I have a 10 to the negative 40th, and I have a 10 to the negative 24th, so I'm actually going to combine those guys together. Okay, so I have 46.7 times 10 to the negative 64th, but I don't want to leave it with 2 digits here, so I'm going to move that over 1, 4.67, which means I need to increase that. Now be careful, when I increase it, I'm at a negative 64, so the increase would actually be to go to negative 63. So be careful that when you increase that, that's what we do there. Alright, and that's that one. Let's look at one final one, number 39, which is a word problem. The volume of a circular cone can be determined by the formula 1/3 pi r squared h, and we're going to use 3.14 for the value of pi to solve for this equation. So here's what it looks like. We have our equation. Oops, let's make sure you see your picture. We have 1/3 pi, and then our r is 6b to the 4th, and that whole thing is pi r squared, so that's going to be squared, times our height, which is 8. So that's what my equation looks like when I set it up. So let's break it apart. We have 1/3 times 3.14 for pi. I'm going to go ahead and do 6 squared for this to give me 36. I'm going to go 2 times 4 for a b to the 8th power, and I still have an 8. So now I've taken this and broken it apart into all my various segments, and when I run it through my calculator and go click, 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 I end up with 301.44 b to the 8th power, and this is inches cubed because we're talking about volume. Alrighty. So there you go. Hope that helps out a little bit. Have a great day.